First, Democritus. Somebody, raise your hand. Tell me about Democritus, what his model looked like, things like that.
He didn't make a model, he just talked about it. He was a philosopher.
He was a philosopher, didn't really have a model, more of a thought model, if anything. Although he did coin the term what?
Atom.
That's probably the thing you need to know for sure about him. That he coined the term the atom. And then along came Dalton. He's known for coming up with, or helping to come up with a law. What's the law?
The law of definite composition.
Yeah, law of definite composition or definite proportions. Either of those will work, which was essentially that every time you break a compound down, he noticed what?
There was still there. Or, no, but
Yes, I hope so.
is that small thing?
That every time when he broke something down, he noticed that there was the same exact ratio of elements by what? Per what? Mass.
You gotta be careful with that. He probably didn't know that it would explode if you split it out.
Well, he isn't splitting an atom.
Yeah, I
He's
know,
taking a compound and breaking it down
I
into
know,
its
but
atoms.
you have to be careful.
Sure, I don't. Well, it's not something you could just do
Like,
easily.
with scissors, when you cut a piece of paper, it's not like exploding out.
Yeah, I understand that.
Separating the bonds. Okay. Then came J.J. Thomson. He's known for discovering what? The electron. He did it using the what experiment? Cathode ray experiment. Okay, very important. Okay, I'm not going to go into the very nitty-gritty details of his experiment, but you should know the highlights of it. He's known for what is his model called? Plum pudding, and you could probably explain what is plum pudding and how he was able to how he deduced that he needed to have a positive portion of his model, right? Because he's got negative electrons, so he had to somehow figure out how in the world an atom's neutral when he found that there were negative things in there and never discovered anything positive. Rutherford then discovered what? The nucleus using what experiment? Okay, the alpha particle gold foil experiment. He shot the alpha particle straight through, and what he assumed would happen was that all of them would go straight through. Some of them did not, even though most of them did. And he deduced that it was hitting something inside the atom, aka the what? Nucleus. Okay, and then we got Bohr. He's most famous for developing what? Energy levels. Okay, energy level 1, 2. We're going to talk much about this today. Okay? Now, he was right about the energy levels. What was he wrong about?
That they go.
That they orbit like planets around the sun.
Yes. Okay? Yes, they do have movement and they are doing things, but they're not orbiting like planets orbit the sun. Okay, along came the quantum model. You with me, guys? Along came the quantum model where it introduced what? What was the really important new introduction? Okay.
3D
Orbitals is really what was the main, I guess, continuation or extension for quantum guys.
So if I finish it, I get after.
What? Yep. So, I think that about summarizes it. Here we go. I'll be right back.
I was like, oh, I feel so accomplished. I finished something. Full biology.
In your pocket.
I finished it in TA. Oh yeah, I did that. Yeah, I didn't know. The book. This is what happens when you That's true. I couldn't get my book. Or here's what happened. I think she let when you order
Exactly what was on the test.
I studied.
All right. Okay, this stuff that we're going to be talking about is new stuff, so it's not like you can just mess around And oh, just a little refresher you need for physical science and you'll be good. Okay, because this stuff builds and it builds quickly. Okay, so please, we cannot do what we're going to do tomorrow, which is a very, very big day tomorrow, if we do not know how to do today. Okay?
Today, October 2nd.
So, okay. So, we do know that Bohr came up with the energy levels. We use the principal quantum number to identify the main or the primary energy levels within an atom. And if you remember from the last week, how many energy levels do we know of? 7. I told you what was the energy levels. 1, 2, 3, 4, 5, 6, 7. And they're the horizontal rows, also known as periods and series. Okay? So, energy level 1, energy level 2, energy level 3, energy level 4, energy level 5, 6, and 7. Quantum number 1, 2, 3, 4, 5, 6, 7. That's what that represents. So if I say quantum number 6, what does that represent? Or, yeah, 6 horizontal row, also the 6th energy level within an atom. Okay, if I say quantum number 4, I'm referring to the 4th energy level within an atom. Okay, very important. When I start identifying, I'm not going to use necessarily energy levels, I might just say quantum number. All right? Now, we talked about how hydrogen only has 1 electron, correct? Okay,
Yeah.
hydrogen only has 1 electron. Well, does that mean it doesn't have all those energy levels? No, it still has all those energy levels, they're just not what? They're not being used. They're not being occupied. Okay, very important. So let me ask you then, as n increases, which is the symbol for principal quantum number, as n goes up, what could you tell me about what's going on when n goes up? There's a few things that are really important. Energy goes up, that's 1.
More electrons.
More electrons, sure, that's 2. What else? That's probably also true because higher energy. Anything else? Further away from the atom. That's also very important. I think that covers about all of it. As I gain in n, or increase in principal quantum numbers, energy levels, not only am I gaining energy, but my electrons are getting further and further away from the nucleus. Okay, a little bit more unstable. All of those things. Very important as we progress here. Now, okay, that represents quantum number. All right, sublevels. Each energy level has sublevels in them. Kind of like atoms have subatomic particles. All right. There are 4 sublevels, and we represent each sublevel with a letter. There's an S sublevel, P sublevel, D sublevel, and F sublevel, and there are orbitals that go with each of those sublevels. Okay? Now, this is very important. Regardless of how many orbitals are each of these sublevels, each orbital can only hold what? 2 electrons. No matter what, whether it's a orbital in the S, P, D, or F, each orbital holds 2 electrons. Well, the S only has 1 orbital, but the P has 3 orbitals. The D has 5 orbitals, and the F has 7 orbitals. Okay, 1, 3, 5, 7. We'll get into that here in a sec when we start going and breaking down each individual guy. All right? I want to put this. Let's see if I can do this right. I always struggle with this. Look like that.
It's a coffin.
So, and didn't want to put, well, I'll give you, well, you don't want it, don't have it yet. And of 1, 2, 3, 4.
Should we draw this?
That's not right. Well. Struggle drawing this. There are 7 energy levels. That's what this represents here. Energy level 1, 2, 3, 4, so forth. Right there.
Well, let out.
Yep. You don't want that. I won't write this in now. I will give you a handout that has this and a whole bunch of other things on it, so you have it all on one little piece of paper. But I don't know if I'll remember or have time to print that out for you today.
Why is it shaped?
You kind of see the progression of increasing sublevels, stays the same, and then decreases in sublevels. Yes.
What equals 1? Like, on the truck, like, what is that?
So that says n, that represents quantum numbers. So n of 1 would be your first energy level, and 2 would be your second energy level, 3 would be your third, and so forth. Does that make sense?
Yeah.
I want you to get this in before I start talking about this. This is really important to be able to get, or at least, I mean, I don't expect you to know every ins and outs of it right away, but at least have this as a resource to tell you, okay, what sublevels are in which energy level? Okay, so here's what this means. We have 7 energy levels. Okay, each energy level represents, each quantum number represents an energy level. In each energy level, there are sublevels. Okay, so here's how we understand this. In the first energy level, what is the only sublevel that's there? In the second energy level, we have 2 different sublevels. What are they? S and P. In the third energy level, we have the S, P, and D sublevels. In 4 and 5, I have all 4 sublevels in those energy levels. In the 6th, we lose the F. In the 7th, we lose the D. Okay? Now, that's important for what we do tomorrow. We're going to need to be able to identify how many electrons are in each energy level. What if I said there are, in the second energy level, how many electrons can fill it? You have to know what are the sublevels, how many orbitals each of those are, how many electrons fill each of those, to be able to know how many electrons are in that energy level. It's a lot. Let's continue on. Okay. S sublevel. Now notice, every energy level has an S in it, doesn't it? Okay? Now, it's the simplest of all. Here's what it looks like. This says 1s, 2s, 3s. What do you think that's representing? The 1, 2, and 3 part of the s's.
5.
Okay? Didn't we say that as you go up in energy levels, what happens? It gets bigger, right? Okay, you get further away from the nucleus as you get more energy, correct? So this would be the orbital for the first energy level S sublevel. This would be second energy level S, so that would be that S. And this would be third energy level S, be that S. Fourth would get even bigger, fifth would get even bigger, sixth would get even bigger, seventh would get even bigger. That make sense? Now notice, S sublevel only has what?
One orbital.
Okay, so if I'm referring to the second energy level, the S sublevel, and those orbitals are full, how many electrons do I have? If I'm talking about the second energy level, just talking about the second energy level's S sublevel, how many electrons can fill it? 2. Because I have one orbital, and how many electrons can fill an orbital? How many electrons can fill an orbital? 2. No matter what orbital it is, S, P, D, or F, doesn't matter. How many electrons can fill an orbital? 2. Now we're going to talk about how P, D, and F have multiple orbitals, but each orbital can only have 2.
This is at most 2. Is there ever only one electron?
Yes, you could have only one or you could have none. Yes. For example, if I'm talking about the hydrogen atom, it's only got one electron, so it's only got one in the 1s. It doesn't have any in the 2s, doesn't have any in the 3s. Okay? Moving on. There's your p orbitals. Notice, your p sublevel has how many orbitals?
3. Sorry.
How many? 3. 3 orbitals. There's a p, I can't tell which is which. It's probably px. No, wait. Px, py, pz. In and out of the page. It's kind of hard to see, but there's your three-dimensional structure. 3 orbitals in the p sublevel. Let me show you something. Actually, before I show you something, how many electrons could maximum fill the whole p sublevel? 6. Each orbital can have 2. If there are 3 orbitals, it could be filled with how many? 6. Let me show you something. What does that say?
S black.
S black. That represents the S sublevel of each energy level. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Orbital, one orbital holds 2 electrons, right? What does that say? P block. How many orbitals fill the P block? Or how many orbitals are in the P block? 3 orbitals. Each can have 2 electrons. So how many electrons could fill 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5, 6. You see how it's this chunk here. D block. Let's talk about that.
We didn't touch on this one last week.
No, I told you that.
Yeah, I know.
All right. How many orbitals fill the D? 5. So if you filled all the D orbitals, how many electrons would you have?
10.
Here's your D block. Right here. Guess how many there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could go all the way down the D block. I've got 10 no matter what. Now, if I'm talking about like cobalt, do all of the D orbitals, are they all full? No. Okay, but if I'm talking about zinc, they are. Okay, we'll get to that a little bit later. What? It's crazy. It's new stuff. I told you this would be new. We'll bring it all together. There's your double-sided pacifier. Love that guy. Okay? So, S has 1 orbital, P has 3 orbitals, D has 5 orbitals. What do you think F has? 7. You're seeing a trend here. Nice thing is there's pretty good trends here. You got multiple double-sided pacifiers on this guy.
Great.
Okay, 7 orbitals. Hey, guess what? There's your F block. Right there. How many do you think there are? 14. 7 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now notice, how many energy levels has F in it? How many energy levels has F? Right at the top left corner over there. 2. 1, 2. How many D's are there? How many energy levels have D's?
1, 2, 3, 4.
1, 2, 3, 4. How many P's?
1, 2,
6.
1, 2, 3, 4, 5, 6. How many S's? All 7. 1, 2, 3, 4, 5, 6, 7. Holy buckets, that's a lot of stuff. Did you know that the periodic table was arranged that way?
No.
Now you do.
Now I see why.
Yes. Okay, and we're actually going to talk about how technically this one really should be up 1, but we'll talk about that later. So, whew, a lot. Here we go. This just says hydrogen's first 4 energy levels. Now remember, hydrogen only has 1 electron, but doesn't it still have all the orbitals? Okay, so the 1 electron's only in the 1s orbital, but it has all the other orbitals. So let's look. Here we go. Energy level 1, we said had the s. Does that agree with this?
Yes.
Okay. So the s can only have 1 orbital, correct? So the maximum number of electrons in the first energy level would be what?
2.
2.
But it's okay.
So you can add another column here. Max electrons, 2. It only has the s, and the s only has 1 orbital, and since 2 fill each orbital, max electrons, 2. Alright, let's look at the second energy level. We got S and P. Now notice, S has how many orbitals?
1.
P has how many orbitals? 3. So how many total orbitals would be in the second energy level?
4.
4, my heavens.
So what is the max amount of electrons can fill the second?
Now I remember 2.
2, 8, 8.
It's actually 2, 8, 18. But, yeah. Okay, so let's look at the third energy level. We know we got S, P, and D. The S has 1, the P has 3, and the D has 5 orbitals, correct? For a total of 9 orbitals. How many electrons fill an orbital? How many electrons fill one orbital? 2. If there are 9 orbitals, you got how many electrons could fill the whole thing? So let's look at the second energy level. Let's count left to right. Everybody.
1, 2, 3, 4, 5, 6, 7, 8.
Does that agree with second energy level, max number of electrons? Okay, here's where this actually bumps up, and I'll explain that why later. But the third energy level is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, you won't know why, but the reason why they put it down is for something later. Alright, let's look at the fourth energy
Is that why
level.
they're called the transition elements?
I don't know if that's why you would call them. I'm not sure.
No, it's still this.
Alright, so we got all 4. S, P, D, and F. The S can hold 1, the P can hold 3, the D holds 5, the F holds 7 orbitals. How many total orbitals we got? 16. Max electrons would be
32.
32. Good. And technically, this goes in here.
Yeah.
And so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Good. It's a lot. That clock's not ready to. How much time we got?
You got,
Oh, sweet. 11 minutes. Nice. Questions so far? It's a lot. I'm going to ask some questions, see if you guys can answer them. You ready?